So this video on circular motion goes through centripetal force in a little bit more depth. The first equation to always remember is F equals ma. That is your friend, never forget it. And from the last video, we saw that A equals v squared over r, acceleration, velocity, and radius. So we can now replace the A for v squared over r, so we get centripetal force equals mass times velocity squared divided by radius, mv squared over r. But as a reminder, we also have v equals omega r as well. So we can put this equation into this part of the equation here, the v squared, so we get with cancellation m omega squared r. But the main one is definitely mv squared over r. And that's because there are so many other equations that begin with force equals, so g m1 m2 over r squared for gravitational fields. We've got another one, q1 q2 over 4 pi epsilon naught r squared for charges, and there are many more as well. It's a really good example of a synoptic element of the course where you've got to merge this equation with anything that goes round in a circle. Another synoptic element is in mechanics. When you go round in a circle, the faster you travel, the greater the centripetal force is needed in order to do so. So, safely, next time you're on a bike, try and go round in a circle faster and faster. And what you'll find is you'll get to a point where you need to compensate and you'll end up getting a larger radius. You'll move further away from the centre of your circle because there isn't enough friction. The force pulling you in as you go faster needs to get bigger and bigger and bigger, and that's when, of course, accidents might happen. Take care. Particularly on an icy surface or a wet surface, the friction is not there, the centripetal force is less, so that's when the accidents do happen. So let's look back at the equation, mv squared over r. So if the road conditions remain the same, then the force will remain the same. So what other factors are there? Well, the mass, that's unlikely to change, so that just leaves us with v squared and r. So if I rearrange, F times r equals mv squared, that tells us that r is proportional to v squared if we're assuming F and m remain constant. In other words, if you increase your velocity, the radius will have to increase in order for everything else to stay the same. Another one is that feeling that you might get in a lift. When the lift is about to go up, it makes you feel slightly heavier. There's an additional force acting on your body, accelerating you up. And it's opposite again, you might feel slightly weightless when it slows down again. Well, let's apply that to a circle because similar stuff happens. Let's be mindful that the weight does not change, but your contact force will vary. Let's explore that a bit more. Let's start with our equation, F equals mv squared over r, and let's be mindful that the mass, the velocity, and the radius are going to be constant. So it's the F, the centripetal force, that we need to focus on. Let's start at the bottom of our circle. So here we are. Our weight is acting down, mass times gravity, and we have a contact force going up, and I'm going to call that RB for R bottom. So to keep going round in a circle, the centripetal force must be larger than the weight. So we've got the weight acting down, the contact force going up, but don't forget this force here always acts to the centre. So in order to compensate, the centripetal force must be larger than the weight. So we can write the centripetal force is actually equal to RB, our contact force, take away our weight, and then that gives us our constant we mentioned earlier. And you might have noticed it, but that's when we feel heaviest. We feel heaviest at the bottom because the contact force is much bigger, so we get pushed into our seat more. Let's look at the opposite at the top. So we've still got the weight acting down, that won't change. However, the reaction force is now in the same direction, and I'm going to call that RT for R top. Both forces act in the same direction, so that means they need to add together, and they together give us our centripetal force. So the equation for this is our reaction force at the top needs to be added to our weight, mg, and that gives us mv squared over r. So this is why it's important when designing roller coasters, because if you're not travelling fast enough when going around in a loop-the-loop, you might fall out. The other option is to look at it at the side. Now what you'll notice is the weight still acts down, and the reaction force goes towards the centre of our circle. Now you should have also noticed that they're perpendicular to each other, so they do not talk to each other, they're independent of each other. So that means the only force acting towards the centre of the circle is our reaction force at the side, Rs. So our centripetal force, Rs, doesn't have any weight component, and that alone equals mv squared over r. That brings us to the end of this video. If you have any questions, get back to me, and don't forget to subscribe.